The next we have the electrode potential and cell potential. The cell potential, which tells us about the amount of electricity which has been generated during the electrolysis, and which is nothing but the sum of the electrode potential of both the electrode, that is anode and cathode, I can say. Now here, suppose what is, first let us try to understand what is electrode potential. So suppose I have an electrode, that is a metal and electrode type, that is a zinc electrode placed in zinc sulfate solution. So if it is a zinc electrode placed in zinc sulfate solution, let this is a zinc electrode. The same electrode again I am considering, that is a zinc electrode only. This is also zinc electrode and this is also zinc electrode. Both are kept in 1 molar zinc sulfate solution let. So here also 1 molar zinc sulfate solution. Now say when the zinc electrode is kept in a zinc sulfate solution, so depending on its electrode potential, or depending on, I can say, that another electrode with which it is associated, it will either undergoes oxidation or it will undergoes reduction. When a particular electrode is connected with the other electrode, then one out of these two, one undergoes oxidation and other undergoes reduction. For example, in the Daniel cell, zinc was linked with the copper, and since the zinc SOP value is higher than copper, that's why the zinc undergoes oxidation. But at the same time, suppose if I am linking the zinc with magnesium electrode, when it will be a club with the magnesium electrode, then magnesium SOP will be more, so magnesium will undergoes oxidation and zinc will undergoes reduction. So whether an electrode will undergoes oxidation or reduction, it depends upon its SOP value or SRP value, I can say. Here I'm considering both the criteria of the zinc electrode. Let's suppose if what happens when the zinc undergoes oxidation, and the second case, what will happen if it is undergoing reduction. So let here I'm considering that here the zinc electrode undergoes oxidation. Now what happens in case of oxidation? During the oxidation, the zinc electrode starts splitting, or the deterioration takes place. The zinc atoms comes out from the electrode and get oxidized to zinc ion. That means here the zinc electrode contains zinc atom. During the oxidation, that zinc atom start converting into zinc ion and produces 2 electrons, and which remains on the surface of the electrode. That means zinc ions get mixed with the solution. The zinc ion get mixed with the solution while the electrons remains on the surface. And since electron get deposited on the surface, therefore I can say that the electrode contain negative charge, and the zinc ion is getting into the solution, and that's why the zinc ion will have the solution. In solution, I can say that the number of positive ions increases because of oxidation, and so that I can say that the solution will have positive charge. So here I can see on the surface of this metal electrode, you can see that the two opposite charges has been developed, that is a positive charge and negative charge, when the oxidation is taking place. Similarly, suppose here I am saying that here let us consider the reduction takes place. Now what happens in case of reduction? Reduction means the solution is containing the zinc ion and sulfate ion. So during the reduction, what happens? The zinc ion from the solution gains electron and get converted into zinc, and that zinc atom get deposited on the surface. So here we can say that the zinc ion from the solution is getting deposited on this, that is on the metal surface. So ultimately what will happen? Inside the solution, the number of positive ions will decrease. That means since the number of positive ion decreases, therefore I can say that the solution is getting negative. The negativity increases inside the solution, and this electrode, where this electron comes from electrode, the zinc ion reaches to the electrode, it gains electron, that means the electrode is losing electrons. Zinc ion is gaining from the solution, that means the electrode is losing electron, and that's why the electrode will have positive charge. So I can say that again in this case, during the reduction also, you can see that on the surface of the electrode, the two opposite charge has been developed. So when two opposite charges are getting developed on the surface of the electrode, then in that case electrode potential is a potential is developed on the surface of the metal, and that potential which is developed due to the opposite charges on the metal surface is called as a electrode potential. So here the electrode potential, the potential has been developed because of oxidation. That's why it is called as SOP, that is a, or it is called as oxidation potential, because here the potential has been developed because of oxidation. So oxidation potential. Here the potential develops because of reduction, so that potential will be called as reduction potential. The potential is generally represented by the capital letter E. So here EOX, that is a oxidation, ERED, that is a reduction. For a zinc, when we measure its oxidation potential, we come to know that the oxidation potential for the zinc is 0.76 volt. And when we measure the reduction potential, we come to know that the reduction potential is also 0.76 volt, but with the opposite sign. Means I can say that for a metal electrode, it's the oxidation potential and reduction potential values are same, only the signs are different. If one is a positive, then other is going to be a negative. If the oxidation is positive, the reduction will be negative. If the reduction is positive, then oxidation will be negative. Only the numbers are the same for whether it is a oxidation potential or reduction potential. So during a oxidation or reduction, whatever is taking place on the electrode, I can say that during that process or during that process, the opposite charges developed on the electrode, and due to which the oxidation, due to which I can say that potential is developed, and that potential is called as electrode potential. So now we learn about the electrode potential. Now let's see what is cell potential. So let's see what is cell potential now. So for understanding the cell potential, I am considering again a Daniell cell. The Daniell cell where the zinc electrode and the copper electrode we have. The zinc electrode which is acting as an anode, and the copper electrode which act as a cathode. Then there is a salt bridge. Filled with some electrolytes. Here we have the zinc sulfate solution. And this is zinc electrode. Here this is copper electrode. And here in the solution we have copper sulfate. That is CuSO4 solution. The zinc electrode, here the oxidation takes place, and since the oxidation takes place, so I will say that here the negative charge will develop and then positive charge. Here the positive charge will develop and the solution will have negative charge. The solution will have negative charge. Now I just wanted to know the cell potential. The cell potential which tells us about the, we are talking about the Daniell cell, which is a galvanic cell. Galvanic cell where the electricity is generated. So that cell potential will tell you that how much amount of electricity is generated during the process, and that value is measured with the help of galvanometer which is attached here. Now how much potential, now how to know that without carrying out the experiment, now how to know that how much will be the cell potential? Then simply I will say that the cell potential will be a 1. See the potential, the cell will works only when both the electrodes are having a different potential. If both the electrodes have a same potential, the cell will not works, and because no electricity will pass. So electricity is generated only when the two electrodes with the different potential is connected with each other. So here, suppose I just wanted to write the E cell, that is a cell potential, then simply I will say the cell potential is nothing but the sum of the potentials of the electrode. Sum of the potentials of the electrode, that is the potential of the zinc electrode and the potential of this copper electrode. So simply I can say the potential of zinc electrode plus the potential of copper electrode. The zinc electrode where oxidation is taking place, and the copper electrode where reduction takes place. or let the zinc electrode where oxidation is taking place, and the zinc electrode value for the oxidation is 0.76 volt, and copper reduction potential value is 0.34 volt. So I can say that on addition it gives 1.10 volt. So I can say that here the potential of this cell is 1.10. This is E cell value, that is a cell potential for the Daniell cell. Okay, now but it's a sum. I had written that it's a sum of the oxidation potential of zinc and the reduction potential of copper, but instead of using this formula we use some other formula. Now let us try to derive the get that formula. Now here the zinc oxidation is taking place on copper reduction takes place. We have the two types of potential, oxidation and reduction, and as I said, if the potential is same, if the electrode is same, then its oxidation reduction values are same, only the sign get changed. Now here the rule says that here instead of considering both the potentials, we prefer reduction potential, always we prefer reduction potential. So rule always says that if you wanted to know the cell potential, then for the cell potential calculation always consider reduction potential. So here I'm going to remove this oxidation potential. Instead of oxidation potential I will consider reduction. However, on a zinc the oxidation is taking place, but still we are going to consider its reduction potential. So if you are considering its reduction potential, then value is going to be same, but as I said, the sign will change. So it will become minus this plus A reduction potential. So now here we are considering both the reduction potential of both the electrodes. Now this reduction potential from the zinc and copper, instead of reduction, I will just write it's a zinc potential plus it's a copper. But it is confirmed that we are considering the reduction potential for both. So it will become the reduction potential of copper minus the reduction potential of zinc. The copper is acting as a cathode and the zinc is acting as an anode here. So we got a formula for E cell. E cell is equal to E cathode, that is a cathode potential minus anode potential. So finally we got a formula for E cell, that E cell is equal to cathode potential minus anode potential, where I know that the cathode is always written on the right hand side minus anode potential which is written on the left hand side. But at the same time, keep in mind that when we use this formula we always consider reduction potential. So while using this formula you have to consider the reduction potential value. Now whether the value is going to be same or not, let's see. By using this, E cell is equal to, I said, E copper minus E zinc. E copper, the copper, it's a reduction potential for copper is 0.34 minus for zinc it's a oxidation for zinc oxidation potential is 0.76. that means the reduction will be minus 0.76. And finally this minus will become plus, so ultimately we are adding only. So whether you consider oxidation or reduction potential, the value is going to be same. That's why we always consider this reduction only, that is to remove that confusion. Okay, then this is a cell potential. The next we have standard cell potential. Standard cell potential, or I can say standard electrode potential. When I'm saying E cell, it's called cell potential. When I'm saying EOX, it is called oxidation. ERED, it's called reduction potential. But if I'm saying E naught cell, then it is called standard cell potential. That naught means standard. And if anyone is asking me the formula for the E naught cell, that is a standard cell potential, then formula will changes to E naught cathode minus E naught anode, or I can say E naught of RHS, that is standard right hand side electrode potential, minus standard left hand side electrode potential. So if the question is based on standard potential, then you have to consider the standard electrode potential only. And for the Daniell cell, this value is not the cell potential, but this is the value of standard cell potential, I can say, that is E naught. Now what is the difference between the E naught cell and E cell? See, you carry out the reaction or the whole process anytime, with any concentration or with any type of electrode. It will be called as a cell potential. For using a standard word, we have some criteria. There is a certain criteria for using that standard word. Criteria number 1. The concentration of all the solution should be 1 molar. For example, if I am using 2 solutions here, that is a zinc sulfate and copper sulfate, then the concentration of both the solutions should be 1 molar. Temperature should be equal to 25 degrees Celsius during the electrogenesis, that is 298 Kelvin I can say. The pressure should be 1 atmosphere, and all the substances, all the components or all the things which are involved in electrogenesis should be in pure and stable form. Under standard condition. For example, if anything is at a room temperature, if anything is in a liquid state, then it should be in a liquid state. It should not be in a solid state. Or if anything is in solid, then it should be in a solid state, not in a liquid state. Suppose if I'm using, once I said it is a standard cell potential, means here the copper sulfate is 1 molar, the zinc sulfate is also going to be 1 molar. The zinc and copper are exact pure electrode. Suppose instead of 1 molar, if I am considering 0.5 molar copper sulfate, then this will not be called as a standard cell potential. Instead, it will be called as only cell potential. So for using a standard cell potential value, that is a standard word, these are the conditions. Or I can say that once I said it's a standard cell potential, that means the concentration is going to be 1 molar, the temperature will be 298, and all the components should be in a pure form and in a standard state, I can say. So this is about the electrode potential and about the cell potential.